Good evening. Welcome to this webinar on IoT for beginners using Arduino. First, I would like to thank Sairam Institute of Technology for this opportunity for this webinar. I would also welcome the students of Sairam Institute of Technology as well as the faculty of Sairam Institute of Technology for this webinar on IoT for beginners using Arduino. We are going to get connected for 2 days, so I hope you will have a great learning over these 2 days. So let's begin the session. About Pantech, we started this company in the year 2004 by a team of 4 young entrepreneurs, and initially we started manufacturing development boards, like we started manufacturing microcontroller boards, DSP boards and FPGA boards. And we also developed some solutions for companies, and we are into we have reconfigurable algorithms on AI, based on MATLAB as well as OpenCV algorithms, where you could modify the algorithms according for your own applications. We also have a power electronics division where we manufacture fuel cell kits and renewable energy trainer kits for colleges as well as for companies. So you could log on to our website www.pantechsolutions.net for more information about our products and services which we offer. So about me, my name is Jeevarajan. I completed my BE from Government College of Engineering, Bargur in the year 2002, and my Masters from College of Engineering, Guindy in the year 2004. So myself and my friends, we started this company in 2004. We straight away came from college and we started this company. And initially we started as a training center, and later we started manufacturing boards from 2005 onwards. We started manufacturing microcontroller boards and DSP boards, and we have also completed some industrial projects. My primary expertise is on microcontrollers. I have worked with various microcontrollers starting from 8051 to PIC, AVR, ARM processor, and DSPIC and PSOC from Renesas. And I have also worked on DSP processors from Texas Instruments and analog devices. From analog devices, I have worked on Blackfin and Sharp processors. From TA, I have worked both on a fixed point as well as the floating point, the C6000 series as well as C7000 series. In FPGAs, I have worked on Xilinx and Altera. So on image processing side, I have worked nearly around 300 to 400 algorithms on this 16 years of time. So if you want to connect me through LinkedIn, I have provided my LinkedIn a link on the description box as well as on the PPT. So you could give a connection request and we can connect together. I'm happy to connect with you and we can learn together. So let us start this session. So what you will learn on these 2 days, we are going to get connected for 2 days. Day 1 is about the basics of Internet of Things, where we are going to walk through the basics of IoT, the challenges of IoT, and why we are going for IoT, and what are all the processors involved in IoT, and how to choose a processor, and the basics of Arduino and ThinkSpeak. That's what we are going to cover up today's session. It's going to be a theoretical session on today, day 1. Day 2 is about practical session. I'm going to walking through an Arduino and a Wi-Fi module. We are going to connect humidity, temperature sensor, to the cloud, and how to write the code on Arduino. That will be covered tomorrow, how to interface a DHT11 sensor as well as the Wi-Fi module, ESP Wi-Fi module to an Arduino controller, and how to send this. We are going to write a code for a simple weather monitoring system, how to send this data to the cloud. That we are going to see tomorrow. So day 1, we'll get started with the Internet of Things. So what is Internet of Things? anything which is connected to the internet, like it may be your mobile phone, or it may be a smart TV, or it may be a simple temperature sensors which is connected to the cloud. So it's called Internet of Things. And like it may be for a personal purpose, or it may be for an industrial purpose, for monitoring and for predicting and for surveillance. So these are all the need for sending the data to the cloud. So anything is send the data to the cloud is Internet of Things. So it may be like you could have a master and a slave node. For example, if you take in case of windmills, you will have one master which is connected to the cloud. All the slaves will send the data to the cloud through a Zigbee or a Bluetooth or any RF technology. From that master, it will be connected to the cloud, and data will get accumulated on the server, where it could be analyzed or processed, and it could be you could take a decision on the data. So this is the basics of the Internet of Things. Like you could have a you could merge the technology, like the Zigbee as well as the Wi-Fi. So anything which is connected, it may be a single device or it may be a multiple device which is connected to the cloud, is the Internet of Things. Okay, so why we go for Internet of Things? Okay, basically it's for analytics. So I will explain you the concept of analytics, like why we go for analytics first. To analyze why it happened, like for example, like what is why the data has been, why it happened, and what has happened, and how to make it happen. So in case of agriculture, like if you're going for implementation of IoT on the agriculture to increase the yield, so this data you could get the data from the soil, you could get the data from the air, and you could get the data from the crops, and you could predict the data, like how to improve the yield, as well as like for that purpose, as well as how to prevent in case of like failures. For example, in case of industrial, if you are going to implement an industrial IoT, how to prevent the failures of the machines based on the data which we acquired from the sensors which is fitted on the machines. So that prevention is done through analytics, and to measure and to monitor, to measure on daily performance, to measure the performance on daily, to improve the yield or something, and to monitor and to visualize the data. All these things are done to improve the efficiency of it may be the whatever the use case may be. It may be for agriculture, or it may be for the industry, and you could also store the data. So it gives importance for big data also, like it generates a lot of data when you store it on the cloud. When you have a lot of devices, and if you store a lot of data over the period of time, data has been generated. So it can be accessed, the data can be accessed from anywhere at any place. So that convenience, for that convenience, and for to improve the efficiency and to analyze the performance, we are going for Internet of Things. Okay, so data is getting connected. So even if today you could see a lot of traffic light cameras on the road which is connected to the cloud for anomaly detection as well as for monitoring. Today they are using for monitoring purpose, and maybe tomorrow like they will deploy a deep learning application or a machine learning application to detect the anomaly detection and to generate an alert. So this is the main reason which we go for Internet of Things, for predictive analysis, to predict what is going to happen, like so that we could avoid the failures, we could reduce the cost of damaging the system, and to measure and to improve the efficiency, to measure and monitoring, visualize, to improve the efficiency of the system. So that's the reason we are going for Internet of Things. So how to choose the right processor for IoT? This was the I am explaining this to the context of an embedded system. Whenever you go for implementing an IoT based on embedded system, for example, it may be a simple temperature sensor. which is connected to a microcontroller, or a camera which is connected to a DSP processor or an FPGA, or you could also have a general purpose system, a PC kind of thing, where which the sensors will be connected, which will act as a master, as like ATM machines. It will be connected to the cloud. Okay. First, I'll explain you the difference between these processors. So microprocessors and microcontrollers, right? We have various processors on the market, like we have microprocessors, microcontrollers, DSP processors, CPLDs and FPGAs, as well as general purpose processors like Intel and AMD. In microprocessor, when you go for a microprocessor, it's completely obsolete and it is not used now. It like the 8086 and 8085, like the differences, everything is external in microprocessors, like the memory and the interfaces, everything is external, and you need to do a simple PCB design to connect all those things. The memory part and the interface part, UART or the timer, everything has to be connected. It will be available as a separate IC, integrated circuits, which has to be connected to bring it as a single system. Whereas in microcontrollers, everything is available on a single chip. It means it is a single integrated circuit. Okay, so you have timers, you have the memories, the program memory and data memory, as well as you have the interface like UART and SPA and I2C interface. Everything is available on a single chip. Whereas microprocessor, everything is external, you have to connect. So that's the difference between a microprocessor and microcontrollers. There are even microcontrollers are available even for 40 rupees, like the 8-pin IC. You could get a microcontroller with 8-pin IC, which is used for toys. So if you want to implement a simple IoT system, like if you like a weather monitoring system, or like if you want to connect a temperature sensor to a microcontroller, then you could choose a microcontroller with 8-pin IC or a 8-bit. You have because you have, like, depending upon the complexity, you could choose whether you need a 8-bit microcontroller or a 16-bit microcontroller and 32-bit microcontroller, okay, which has the capability to solve that data. Whereas in DSP processor, for example, if you are going to implement a complex algorithm where you have to interface a camera to the system, camera or an audio to the system, then you could choose a DSP processor. Because DSP processor has the capability to do a complex mathematical calculation, whereas microcontrollers cannot do a complex mathematical calculation. So if you want to run an image processing system or a video processing system, then you could choose a DSP processor. A DSP processor is nothing but which has the capability to do a digital signal processing. Okay, so digital processing algorithms on DSP processors. So then you can choose a DSP processor. We also have CPLDs and FPGAs. The only difference in CPLD and FPGA is it can be customized. It's like a tailor-made. Like you could change the pins. Whereas in microcontrollers and microprocessors, the pin definitions, they cannot be changed. Like for example, the UART pins can be used only as a UART pin, and like if it is an SPA, you could use that pin as only as SPA pin. Whereas in this CPLD and FPGA, you could customize the pin and you could change the architecture. So it's tailor-made. User can customize. Whereas the microcontroller, user cannot customize. CPLD are complex programmable logical devices which will do the role of a microcontroller. You don't have the capability to do a mathematical modeling on a CPLD processors. So if you want to, but it can be customized. So if you have a microcontroller applications, but if you have a requirement to customize, then you could choose a CPLD processor. Okay. On FPGA part, if you want to do a mathematical modeling, all the DSP application can be implemented on FPGA. Right? All the DSP processing can be implemented on FPGA. The only difference is FPGA can do parallel processing, whereas DSP is sequential. It cannot do parallel processing. But there are some recent processors which come up with 2-core and 4-core processor, like 2-core in a single chip can do parallel processing. It can run two parallel algorithms, whereas FPGA, it is phenomenal. Like you could also do a four algorithms at a time, but the algorithm should be on parallel. Okay, so then you could go for FPGA. If you want a parallel processing to be implemented, then it's better to go with FPGA. And if whenever, like if you like more speed and like more, like if you want to handle the more data, then it's better to go with the Pentium 4 or Sairam processor, AMD processors, which is not recommended for an embedded system, because this will generate more heat, and it needs like wherever you have a wall mounted power supply, and where power is not a constraint, and then you could choose this device, Pentium 4 or Intel Celeron, where you have to deal with mass data. Then you could choose the general purpose processors. But when you go for an embedded system, like only embedded system is nothing but a system which will do a specific task. Okay, so that is embedded system. When you design an embedded system for IoT application, then you could choose any one of this: microprocessor, microcontroller, or DSP processors, or CPLDs or FPGAs. Okay, so I will repeat: microcontrollers for simple applications, DSP processor for complex mathematical applications, and FPGAs will do the role of the DSP processor. The only advantage with DSP processor is it could do parallel processing, and it could also be customized. You could also customize the FPGA processor. Whereas CPLD, it will do the role of a microcontroller, and the only advantage of CPLD is you could customize the architecture as well as the pins of the CPLDs, which is not possible on microcontrollers. So these are the processor selection when you go for designing an IoT based embedded system design. So there are a lot of manufacturers available, like Dallas, Philips, Renesas on microcontrollers you could choose. And if you check the DSP processor, you have Texas Instruments, Analog Devices. These are all the manufacturers for DSP processors. The popular is on Texas and Analog Devices. Whereas if you go for microcontrollers, the popular is the Microchip as well as the Texas Instruments and the NXP, like Philips NXP for 8051. So these are all the popular manufacturers. And like general purpose, like you have Intel and AMD, and Broadcom, Qualcomm is also there for mobile processors. So coming to challenges in IoT. So one challenge is the scalability, right? Devices, you are going to add more number of devices. Maybe in 2020, already millions of devices is already recording the data, and more than trillion of devices will be added again. So the system should be capable of handling much more devices on the cloud. If you check today, previously before 10 years back, we used to have only one phone, or like 15 years back, we used to have only one phone on home, like one telephone on our home. Today we have a mobile phone for each and every person on the house. So everything is getting connected to the cloud. Okay, similar case, you will be also having a wearable which will be reporting to the cloud how many steps you walk and everything. So we are getting more and more devices are getting added to the cloud. Smart TVs is getting connected to the cloud. So once you add more and more number of devices, then security becomes a problem. Hacking the devices will be common. So your devices should be much more rugged, your devices should have a cryptographic technique which will encrypt the data, so such a way that it's not possible to hack the system. So security is a key constraint and a challenge on IoT. The third point is the power consumption, low power. For example, if you're designing a simple IoT on a temperature-based simple IoT system, it should be battery operated for 2 years on agriculture field. If you're going to implement that on agriculture field, and if you're going to keep changing the batteries for every 2 days, then it's not going to work. So it should be such a way like the device should send the data for at least for minimum a period of 2 years. It should be operated on the battery, So power consumption should be there, or is a challenge in IoT, and like it should be operated on the low power. And interoperability is nothing but like it should be compatible with the other manufacturers and other protocols, and power supply. It should be capable of handling the power from the battery source as well as the wall mounted power supply if required. And technological standardization should be there, because we are getting a lot of manufacturers over and over again for the past 5 years, and so we should maintain open standards such a way the device will be compatible with other protocols and the other manufacturers. And finally, the fault tolerance. Okay, so these are all the challenges in IoT while we have to consider while designing an IoT based system. So coming to the trends which drives the IoT is on day to day, like sensors are getting more cheaper and cheaper, so that you could implement the data. Like even if you take a camera, most of the homes are now connecting. Most of the homes in US is having the camera connected to the cloud, and they used to monitor on the mobile phones. The same concept will also come to India over the period of time, maybe in the possibly of the 2 years of time down the line. So every home will be connected to the cloud. Every home will have a camera which is connected to the cloud, and data will be monitored through your mobile phone or a tablet or whatever device you may have from a desktop. So this trends are driving IoT, like due to the cheap sensors as well as improved. You are improving the business value, like you are improving the efficiency of the business by connecting the sensors to the cloud and monitoring the data and analyzing the data, where it goes wrong and how to prevent this failures, those things. So these are all the trends which is driving IoT day to day, and IoT is getting more familiar day to day, and it's getting more traction towards day-to-day activity. Okay, so coming to industrial IoT, like industrial IoT is also same as like this normal commercial IoT device. The only thing is industrial IoT is the precision, right? So most of the industrial IoT systems are hard real-time systems. So like it may need you have to take care of the security part, as it's a hard real-time system. So the system should not be vulnerable to attack. And precision is much more mandatory, so you should have a precision sensors as it needs. And the third point is it should be capable of learning on its own, like a machine learning kind of thing, where the system learns on its own and can do a predictive analysis and alert the users. So these are all the things which we need on industrial IoT. And so if you check the difference between IoT as well as the industrial IoT, so if you take the household usage, like it may be a mobile phone or a wearable sensor like Fitbits or any wearable sensors which you have, which will be connected to the cloud, or a video camera for your home for surveillance, or a baby monitoring system which will be connected to the cloud. It's a complete soft real-time systems, whereas the IoT is a hard real-time systems. Like if something happens and you will be losing money, so it should be more secure as well as it should be more precise, and it should not but the data management and connectivity and data security and the cloud, everything is common. Okay, it's common for both IoT as well as for industrial IoT. So coming to machine learning, why machine learning is much more important in IoT? Because machine learning is nothing but the machine can learn on its own. As like humans, the machine can learn on its own. Whereas in traditional embedded system, you will be writing the code for the embedded system. Whereas in machine learning, the machine itself will optimize the code for its based on the data you feed to the system, and it learns on the data and it takes the decision based on its learning. Okay, based on its learning, I'm not going to much more detail on the machine learning part, as it's a vast area and you have like supervised and unsupervised learning. So but the role of machine learning is much more important on IoT nowadays, like for predictive analysis as well as the decision making. So machine learning is much more important in IoT nowadays. So to take decision to the so that the machine can take decision on its own. So that's a main advantage of using machine learning and deep learning systems on IoT side. So markets, there are a lot of markets, like you have smart cities, like traffic monitoring system, traffic surveillance system, and like air quality monitoring system, like monitoring the city to air quality monitoring for cities, and parking management system. So all these comes under smart cities. Even cars will be connected in future, so you will have a communication with the cars, and all the data, like data will be on cloud. The car data, the OBD data will be on the cloud, where you could where the service people can analyze the data, what happens to the car, like what is the root cause for the problem. So all the data will be stored from the sensors, and it will be connected to the cloud, and so they could analyze the data. Smart meters, like the EB meter, can be reported to the cloud, so no need to, so the meter reading and everything and payment and everything can be done on the cloud. And retail shops, like the warehouse management, like the stock inventory, the inventory data and the stock data can be uploaded to the cloud, so that the manufacturer can have a look on the retail stores. Previously, they used to walk through these stores, and they take the data manually and they send the data. But nowadays, due to the IoT sensors, they used to get the data from through the cloud, and they used to send the goods, so that they won't lose a sale. Okay. Coming to wearables, like the healthcare technology, like Fitbit, you could monitor your walk, how many steps you take, how many calories you burnt. Everything can be monitored, and you could how well you sleep, and everything can be monitored, and it will predict the data. Okay. And industrial IoT, machine to machine communication, is for industrial IoT. And agriculture, like you could implement this IoT systems on an agriculture field, like on humidity, as well as you could measure the humidity, as well as the you could switch on the motor and switch off the motor based on the soil as well as the air. Everything. You could also monitor the crop, okay, to improve the yield. So these are all the markets. I have put only a few over here, but there are a lot of markets still uncovered. The list goes on, like more to 40 to 50 list goes on. So I just give a overview of this topic. So you could always go for Google, and you could learn more on this data. Okay. So the market situation is growing day by day. So we are getting billions of devices is getting added to the cloud day by day. Like all TVs are converted to smart TVs. All normal mobile phones are converted to smartphones, and watches. Even watches are getting converted to wearables, like have data to measure the heartbeat, as well as the measure the calories and everything. So every device is getting connected to cloud. So if you take an like an analysis, so if you on every single home, you will be having 5 to 10 things will be connected to the cloud. So imagine how many home will be connected to the cloud within the 2 years downline. So you have a lot of potential for Internet of Things. So more and more devices getting added, starting from wearables, starting from monitoring system on the home, and everything is engagement system like TV, or so everything is getting connected to the cloud, or iPods, or everything. Okay. So analytics is the key to getting value to the IoT system. So these are all the market situation. So coming to application, like I'm going to explain some of the applications over there, but we are not going to cover up because it's a vast area. So to give an idea about the IoT, so the weather monitoring using Arduino, which we are going to see demo on this session, on this webinar, like that I have provided a link from makerzone.mathworks.com where you have a code for this, where you could connect a simple temperature sensor to an Arduino, and this Arduino will have an you could interface a Wi-Fi module with that Arduino, and you could send the data to the cloud, and you could monitor the data, and you could visualize the data. So this is available on makerzone.mathworks.com. And you could also have an application for connecting a Raspberry Pi processor as well as the webcam. So you could fetch the data from the webcam for traffic monitoring and traffic analysis can be done on the cloud. So again, that the link I have provided, the link where you could download the codes for the Arduino, for the Raspberry Pi, as well as for the ThinkSpeak. ThinkSpeak is a cloud. I will cover the topic later on this session. ThinkSpeak is a kind of cloud, so you will get both the ThinkSpeak as well as the sample code for Arduino. So Raspberry Pi. Okay. So one more system like which we have developed on IoT is the epilepsy alert system for the patients, for the seizure patients, where they will be wearing EEG headsets, which gets the data from the brain. Like whenever a seizure is attacked for the patients, like this is for the Alzheimer and the epilepsy patients. Okay, so whenever they have a seizure, the EEG headsets gets the data. But this seizure, it's not based on the seizure, like you cannot predict the the seriousness. So we have one more sensors we have on the patient, like the blood pressure sensor. Once you get the seizure, it checks the data from the blood pressure sensor. Okay, it checks the data from the blood pressure sensor, and it also checks the data from the mobile phone, which the algorithm where the algorithm get the data from the accelerometer, whether any human fall is there or not. Okay, so the algorithm gets the data from the once you get the seizure, it gets the data from the mobile phone whether any human fall is detected or not based on the accelerometer. And it also takes the pressure, like it also takes the data from the blood pressure sensor, like the systole and diastole, like whether there is an increase in the blood pressure. So it generates an alert. Once if the patient has a high blood pressure as well as a human fall is detected and the seizure is detected, then it's serious. The case is serious. So the patient needs a help when he go for a walk or when he go for anything else. Okay, that's a stroke occurred, and it generates an alert. To the caretakers, and it fetches GPS data from the mobile phone. And it sends the location of the person to the caretaker, and it also sends the data to the hospitals. So this is an example for an IoT device for a patient, for an epilepsy patients. So you have to you need three variables. Like the one is the EEG headset to get the data from the brain, and blood pressure sensor to get the data from the blood pressure sensor, and the mobile phone for human fall detection as well as for GPS location of the patients. Okay, this is a simple example for IoT system on a health monitoring. And one more application is an application from a company called Building IQ, where they developed a HVAC system, like the heating, ventilation, air conditioning system based on ThinkSpeak, and they used a machine learning algorithm, so that this is for energy consumption in homes as well as for in office. Okay, they have pressure sensors, and they have control units for controlling the air conditioning units as well as the temperature sensors and power meters. Okay, this is one example for reducing the cost of electricity in offices as well as on homes. Okay, and again, one more application is from a company called Isonia, where they manufacture respiratory monitoring systems. So based on the wheeze detection as well as asthma management, which is sent to the mobile phones, which gets the data from the sensors and sent to the and the data is sent to the mobile phones, and the mobile phone is again connected to the cloud. And the data has been sent to the in order to avoid that frequency of visits to the doctor, right? For the for the patients, for the asthma management, for asthma patients. Okay, so these are all the few examples of IoT. So the next thing is how to implement a simple IoT system using Arduino and ThinkSpeak. So that's what we are going to learn. So I'll give you the introduction part of the Arduino and ThinkSpeak today, and later we will be covering up the hands-on session tomorrow. Okay. So what is Arduino? Arduino is an open source hardware and software company. Basically, it manufactures Arduino development boards from based on AVR microcontrollers. AVR is it's a brand managed by a company called Microchip. Previously, it was from Atmel. So Microchip, they bought the Atmel companies and they merged with their product line. So Arduino, the one advantage of Arduino IDE is the software. Like they have their own IDE, where you no need to worry about the like the details of the microcontrollers, about the registers. You have a lot of inbuilt libraries. So no need to worry about the worry about the registers, and you could directly everything can be implemented in a single line of command. For example, if you want to send the data, serial data, you could type a single line of code called serial, and if you want to blink LED, you could directly choose a pin and you could give the data, whether it is 1 or 0. You could also read from the pin. So pin mode, pin, you could write the data or you can read the data very easily. So that you could concentrate only on the application part. No need to worry about the details of the. Whereas when you go for a same coding on an 8051 microcontrollers, it will take a lot of time. Like you want to go through the registers and everything, and you have to feed the data. Whereas in Arduino, it's very simple. So whenever if you want to implement the application very faster, then you could go for an Arduino. Else you go with the traditional line of programming. Okay. So they come up with a lot of boards. They have Arduino Uno, Arduino Mega, and Lilypad, and Nano and Mini. So Uno is the basic version and the popular version, whereas Mega, it has lot number of IO pins when compared with Uno. So if you have a complex application, for example, if your application needs 2 or 4 UARTs and it needs more speed and memory, then you could go with the Mega version. Lilypad is for textile technologies, textile electronics, as well as for wearable electronics. So Lilypad is manufactured for that, and Mini is also for like the wearable kind of thing. It's very miniature in size, and you could, for a simple toy kind of application, you could go with Mini or Nano. So we are going to see demo on Arduino Uno. So Arduino Uno, so these are all the features. You have a USB port to give the power through the USB port. The same USB port can also be used as a serial port. Okay, you could also give the power from the jack. You have a power input port, and you have the PWM pins, right? You have the PWM pins over here, and GPIO pins here, as well as you also have the analog pins from A0 to A5, 6 analog pins, and power supply pins. You have 5 volt, 3.3 volt, as well as ground. Okay, and all the digital pins, and you have an option for ICSP, that is in-circuit serial programming, where you could program this device through a serial port. Okay, you could also program this Arduino Uno by this USB port. If this USB doesn't work, then you could use these pins for programming this microcontroller. Okay, it supports in-circuit serial programming. It means programming the microcontroller through the serial communication, like through the serial port. These are all the features of the serial port, and this IC is FT232, which act as a UART bridge, USB to UART bridge, as well as you could also program the microcontroller with this FT232. Okay. So coming to the cloud, we are going to use the ThinkSpeak cloud. ThinkSpeak is a cloud which is provided by a company called MathWorks. So they also offered a tool called MATLAB, which is used for simulation, like for algorithm and simulation tool. So ThinkSpeak is a cloud which is provided by MATLAB, where you could store the data, as well as you could also analyze the data, and you could predict the data. That's the advantage of ThinkSpeak. Okay, so you could analyze the data easily. You could write the code on MATLAB, or you could write the code on you could also implement the machine learning algorithms on ThinkSpeak very easily. And you could also send triggers, like to send an SMS, or to send a tweet, or to send a Facebook post, or to send a WhatsApp message. That anything is possible on this ThinkSpeak by using one more tool called IFTT, like if else then that. Okay, so to analyze, so it has its own analytic platform, like to let the graph, or a bar graph or a pie graph, whatever you want, you could have. You could analyze the data, you could implement the machine learning algorithms, as well as you could also act on the data. You could also send tweets, and you could also send SMS. You could also generate alerts. So that's the advantage of ThinkSpeak. The other IoT clouds are like you have Microsoft Azure, and Google Cloud, and Amazon Web Services, and IFTT, like if else then that. Okay, if this then that. So ThinkSpeak is for makers, for academics. It's free. You could also create an account on ThinkSpeak, and you could start developing your IoT applications on ThinkSpeak. Okay, so first I will explain you the ThinkSpeak on this presentation. Then we can open the ThinkSpeak website, and I'll show you like what is there on the website, and how we are going to connect with this ThinkSpeak. Okay, so ThinkSpeak will have channels. Each channel will have 8 fields. It means you could connect 8 sensors, like temperature sensor, the humidity, or any air quality monitoring system sensors. So for each channel will have 8 fields, where you could connect 8 sensors to the sensors. Okay, so it may be temperature and humidity and etc. Okay, so the first thing you have to do is to create an account on MathWorks. It's free. You just create an account on MathWorks. Once you create an account, you will ask for it. It will send MathWorks will send an email for verification. You have to click the email to verify your account. Once it gets verified, you get a home page like this. Okay, you get a home page once you log in on the ThinkSpeak website. You'll get a home page like this, where you could view your channels. You could have any number of channels, and each channel will have 8 fields. You could get the data from 8 fields. Okay, so the channel, you could also the channel may be a public channel where anyone can view, or it may be a private, only you can view the channel. So there are 2 options, private as well as public. Public, anyone can view the channel, so there will not be any access. So if once you publish the channel, everyone can see the data. For example, if you take a cricket score, if anyone of the public wants to see the data, then that will be available as a public one. Whereas the private one is like only the one have the credentials can view the data. Okay. The next is the API keys and the data import. Okay. So first thing is to create a channel. Once you create a channel, it will ask for fields. You can create 8 fields. For example, if you have only 2 sensors, if you have only if you want to report only the humidity and temperature, you just create only 2 fields. Okay, then once a channel is created, now it's ready to accept the data, to accept or to write the data. Okay, to write the data, so like you need the API keys. You have a key called API key, which I will explain you now. Before that, there are a lot of templates available on the MathWorks websites, where you could make use of the code. For example, if you want to calculate and display an average humidity, there's a code. You choose this template. So MATLAB itself will give you the MathWorks, the ThinkSpeak itself will give you the MATLAB code for this. And you could calculate the wind chill, and like you could calculate the temperature, and you could trigger an email. So you have the template code. You could choose the template for creating the code. Okay. Then the read and the write API keys. write API key is there and the read API key is there. So for if you want to write the data to the channel, you have to use the write API key. If you want to read the data from the channel, then you have to use the read API key. Write API key and the read API key. Okay. So these are all the API key settings which you will be using it for programming. So that's all about today. So tomorrow we will be completing, like we will be going through the programming in Arduino basics and how to interface DHT11 sensor with an Arduino and how to build a cloud-based weather monitoring system. So that's a hands-on session. So that will be covered up tomorrow. Before that, I'll show you the ThinkSpeak cloud. Okay. So I will show you I will log into the ThinkSpeak account and I will show you the same thing on the cloud. You just go for thinkspeak.com, click for login. So already I have logged in. So go for my account. So, channels, click my channels. So these are all the channels what we have in our system, like automatic diagnostic system as well as the weather monitoring systems. So you could create a new channel by clicking this icon, new channel. Once you click new channel, so you could give a cloud-based, we are going to do a cloud-based weather monitoring system. Okay. So you could have any number of fields. So I'm going to choose two fields. One is for the humidity. Okay. The other one is for the temperature. Okay. I'm going to have only two fields. You could give a description if you want and save the channel. So once the channel you get two fields, field 1 and field 2. Okay. This is the humidity and this is the temperature. You could also go for click MATLAB analysis to do a MATLAB analysis and MATLAB visualization to visualize this one. And here is the API key. You click API key. This will give you the write API key as well as the read API keys. Okay. So this is important. When only this key you will be using it in Arduino to send the data to the cloud or to read the data from the cloud. Okay. And sharing. Here you could give the options whether it is private or whether it's public. So that settings will be there in the sharing. And channel settings, like the channel ID is important to send the data, and public view, and this is on private view. Okay. So these are all the settings on the ThinkSpeak cloud. So tomorrow, like we will have a hands-on over this session. With this, I close this session. I once again thank you for this webinar, for coming to this webinar on IoT for beginners. Thank you so much, and thank you once again. See you on the next session. Until then, bye bye. Thank you. Have a great